Hello everyone, welcome to our channel AskPrep. In today's series on 11th grade chemistry, we will be studying chapter 13, hydrocarbons in detail. Let's start the video. Starting with hydrocarbon. A compound made of carbon and hydrogen is known as a hydrocarbon. Saturated hydrocarbon. A hydrocarbon is said to be saturated if it contains only C single bonds. Example, ethane, CH3-CH3. Alkanes. Alkanes are the simplest organic compounds made of only carbon and hydrogen. They have the general formula C to the power of NH to the power of 2n plus 2, where n equals 1, 2, 3, etc. The carbon atoms in alkanes are bonded to each other by single covalent bonds. Since the carbon skeleton of alkanes is fully saturated with hydrogen atoms, they are also called saturated hydrocarbons. Alkanes contain strong C-C and C-H bonds, making them relatively chemically inert. Hence, they are sometimes referred to as paraffins, from the Latin parum affinis, meaning little affinity. Next is alkenes. Alkenes are hydrocarbons that contain a carbon-carbon double bond, C=C, in their molecules. They have the general formula C to the power of NH to the power of 2n. Structure. Let us consider ethylene, H2C=CH2, to illustrate the orbital makeup of alkenes. In ethylene, the carbon atoms are sp2 hybridized. They are attached to each other by a sigma bond and a pi bond. The s bond results from the overlap of two sp2 hybrid orbitals, and the p bond is formed from the overlap of unhybridized p orbitals. Ethylene is a planar molecule. Alkynes. Alkynes are characterized by the presence of a triple bond in the molecule. Their general formula is C sub NH sub 2n minus 2. The first and most important member of this series is acetylene, HC=CH. So alkynes are also called acetylenes. Structure. Let us consider ethene, HC=CH, to illustrate the orbital makeup of ethene. In ethene, the carbon atoms are sp hybridized. They are attached to each other by a sigma bond and two pi bonds. The sigma bond results from the overlap of two sp hybrid orbitals. The pi bonds are formed from the separate overlap of two p orbitals from the two adjacent carbon atoms. The other sp hybrid orbital of each carbon atom forms a sigma bond with another carbon or hydrogen atom. Ethene is a linear molecule. Structure of benzene. By elemental analysis, it is found that the molecular formula of benzene is C6H6. This indicates that benzene is a highly unsaturated compound. In 1865, Kekulé proposed a cyclic planar structure of benzene with 6 carbon atoms, where alternate single and double bonds are present. The Kekulé structure suggests the possibility of two isomeric 1,2 dibromobenzenes. In one isomer, the bromine atoms are attached to doubly bonded carbon atoms, while in the other, they are attached to singly bonded carbon atoms. However, only one orthodibbromobenzene could be prepared. Failure of Kekulé's structure. Kekulé's structure of benzene failed to explain its unique stability and its preference for substitution reactions rather than addition reactions. Resonance structure of benzene. Resonance occurs when two or more structures can be written for a substance that involve identical positions of atoms. The resonance structures of benzene explain its stability and behavior better than Kekulé's alternating double bond model. Preparation of benzene. Benzene is commercially isolated from coal tar. However, there are synthetic methods that can be applied in the laboratory for its preparation. See the image. Physical properties of benzene. Benzene is a colorless liquid. It is insoluble in water, but soluble in alcohol, ether, and chloroform. Benzene itself is a good solvent for many organic and inorganic substances, such as fats, resins, sulfur, and iodine. It burns with a luminous sooty flame in contrast to alkanes and alkenes, which usually burn with a bluish flame. Chemical properties of benzene. Benzene undergoes the following types of chemical reactions: electrophilic substitution reactions and addition reactions. See the image. Benzene on treatment with excess of chlorine in the presence of anhydrous aluminum chloride can be chlorinated to hexachlorobenzene, C6Cl6. See the image. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exams.